Welcome everyone. In this session of Data Science for Consultant, we'll talk about advanced analytics. Today I will illustrate concepts of classification analysis using neural networks. In this part, I will also illustrate other tips and tricks to accomplish your day-to-day task. So, to do a quick primer on what is classification analysis. So classification analysis is a technique which is probably most suited for predicting binary or nominal category. It has an input of predictors which results you in a target. The classification analysis is a task of assigning objects to several predefined class. And there are many types and techniques of classification such as decision tree. Obviously, we're going to talk about neural networks, naive Bayes, and others. The performance of classification model is evaluated based on counts of test records correctly and incorrectly predicted by the model. And we'll talk about this as a confusion matrix. So to get started, here is our business case. So we have a sample data of a population with their marketing response. So basically, a marketing agency had sent emails to this set of data or set of population and have recorded their feedback. The feedback is whether they have received any response from the individuals or not. So that is the data. And the goal for us is to prepare a model where we should be able to predict for certain population if that individual in future is going to give us a response or not. So in this way, if you are an analyst, you should be able to categorize those set of attributes which help you filter out those population which are most likely to give you response. So that is the case. In that case, you will save a lot of time and money because you will be sending more targeted marketing campaigns. So let's get started with this SAP's Business Object Predictive Analytic tool. So the first step is to acquire data. And as we see, we'll click this. Since I have recently used this data, it's available here for me. But for some who is the first time or who have saved this in their drive or it's available in other databases, you can choose one or many options and you can pick it up from your local folders or saved folders or even different databases. So in this case, since I had it recently opened, it's available here. So I'm going to select this. Wait to create. Here we go, it's loaded. So let's take a peek in the data so we understand what type of data we have, what are the attributes. So just to quickly go through, we have age of the sample population. We have work class, which is the employer's category of individuals. Ignore this for a moment. We have education. We have education numbers, which is numbers of years of education. If we scroll right, we have marital status, we have occupation, relationship, race, sex, capital gain, capital loss, hours this week, hours per week, how much they work, country, and class is the prediction, or in this case, it is the actual response. So it's a binary data. So if you have a value of 1, that means this gentleman or gentlewoman has responded. So that is how it is. So all the ones are response received, all the zeros are not received. The initial phase of any data analysis is to look for missing values, outliers, and other discrepancy in the data. To do that, we use the visualization part of it, and we will try to the goal is here not to go deep into doing data preparation, but I'll just show you one or two things before we go deep into the neural network analysis. Okay, this is the visualization screen. So here, for us to do some quick visualization, we'll try to find out some outliers, and for this I'm going to choose A's. As you see, the system automatically sums seeing this as a continuous variable, but we don't need, there's no need for summer at this moment, so we will change the categories. We're also going to use the number of years of education for our demonstration purpose. Obviously, you can choose as much as you want, and we will use hours per week. You see, hours per week is seen as a dimension, so we will have to move up as a measure. So we will create a measure on this, and again it becomes a sum. So let's change the aggregation to none. Hours per week. Then we will put class let's use box plot for now. Box plot is a good technique to find out outliers, and just to explain you a little bit what box plots are. So box plot, in the middle, if you see, is quartiles. This is a quartile, first quartile, this is the median, and this is the third quartile, and this is the maximum, and this is the minimum. As you can see, there are outliers here and here, so these are outliers. So definitely there are data which needs to be cleaned up. So let's move on. We can do the similar exercises with other visualization techniques and try to clean up data. It's again garbage in and garbage out. So it's important that we clean data as much as possible before we create a model. So let's try to create a model. So to create a model, we will use the predict tab. As you see, data is here. So for neural network, it is very important, it's a good practice also to normalize any data before training a neural network. This is very important first step, and depending on your data set, avoiding normalization may lead to useless results or to a very difficult training process. So in many cases, the algorithm will not converge before the numbers of maximum iteration, and you can get wrong or faulty results. So let's try to do some normalization for the variables we are going to use, and I'll show you a couple, and then we'll run the neural network. So to normalize, we will have to go to data preparation phase, double click normalization. We'll go to the attributes, configure settings, and let's take age being one of our variable. Let's normalize this. Let's try to normalize one more variable. So we use this. Same thing. We do configure settings. And here let's use hours per week. Same thing. So I think we have two variables. Let's run it. So by running, what happens, you will see that it normalizes, and I'll show you what I mean by normalization in this case. Okay, so if you see on the age now, this is what I mean normalization. So it did put a normal value between 1 and 0. And here you see, so we use age as a normalization, and we also did normalized hours per week. So this also, as you see, got normalized for all the values. If you scroll down, it does normalize all the values. So this data grid, we can see how the normalization has happened. So let's go back to the designer view and let's move on with our process of creating neural network. In this case, we will use the algorithm RR neural network. To this, configure settings, and then let's select the two here which we had normalized, age and hours per week. And our target variable is class, which is our binomial 0 to 1, which 0 being no response and 1 being response to our marketing campaigns. Let's change it to 3 just because we have 3 nodes here. This, and let's run this. So I will run the model to create a model. So execution is complete. So let's pick up. So here we see, if you scroll on the right, we see the predictions, and this was the actual data. So based on the model it created, the prediction was 0, but we had actual results. So looks like prediction is off a little bit, but that will happen. It's because of the variables we have chosen, and maybe also because of cleanliness. So one way to look at how the prediction, how correct it is, to look at the confusion matrix, and I'll try to explain you what confusion matrix is. So this is confusion matrix. It contains information about actual and predicted classification performed by this neural network algorithm. This also helps you to visualize the accuracy, and as you see, it's a n by n matrix where n is a distinct value. So the entries on the diagonal of the matrix represent the correct values, correct prediction, and the entries on the diagonal of the matrix represent the misclassification, entries off the diagonal. So that's also worthy to be noted. And as you can see, if you hover here, you can see actual true positive out of 37,000. And so this was predicted here, 34,000 out of this. And one thing also to note is the model accuracy figures is also very key number here. So as you can see, anywhere close to 80% is unacceptable. So this is a little bit below 80%, but close. So there is still more training to be done on this. Maybe add more variables, because we just used 2. I think if we have used more, this could have been a more robust model. But just to illustrate, this is how we create models for neural networks. So this concludes our session. We will meet again in next session. Thank you. Bye.